Hello everyone, welcome to It's All About Economics, and today's topic is harmonic mean from Statistical Methods Unit 1B. I'm Suraj Sharma. For more details, you can email me or you can text me. Objectives. In last class, we have gone through the geometric mean and uses of it, the mean's extreme property. We calculated geometric mean and meanwhile the merits and demerits of geometric mean. In this particular class, we would be focusing on harmonic mean and the uses of it. We'll let you know how to calculate harmonic mean, having simple examples and merits and demerits of geometric mean. Moving ahead, what the harmonic mean is and the uses of it in mathematics or in statistics. Harmonic mean is actually one of the several kinds of average, and in particular one of the Pythagorean means. Typically it is appropriate for situations when the average of rates is desired. So when you having observations like fractions, rates or multiples, you should definitely use harmonic mean in place of arithmetic mean. If you're interested in averaging things like rates, for example average travel speed, and you have observations like multiplicative or division relationships, you should definitely use harmonic mean in place of arithmetic mean. Financial studies In financial studies, if you're interested in averaging price earning ratios of products or for firms, you should definitely use harmonic mean. In these examples or in rates and multiples, why don't we use arithmetic mean is only because arithmetic mean gives greater weightage to high data points, and in case of rates or multiples this will not work because average arithmetic mean would actually be having bias toward large values. However, harmonic mean equalizes the weights of each data point, since the harmonic mean of a list of numbers tends strongly toward the least elements of the list, and it tends to mitigate the impact of large outliers and aggravate the impact of the small ones. What harmonic mean is used when each observation xi is carrying a different weightage, that is wi, and it can be calculated as this particular formula where h is harmonic mean. In numerator we have the summations of all wi's, and in denominator we have the summation of wi upon xi's. So if you are having k different observations, you can put all of them using the weightages and the ratios of weightage to the observation. Here it is very important to mention that the summation of wi's is actually 1, because these are the weights or the proportions which actually adds up to the 1. And it can also be written as this. So the formula will change it like this: the harmonic mean is actually 1 upon summation of all wi xi, wi upon xi's. I is equal to 1 from k. Harmonic mean can also be calculated for n different observations, and the harmonic mean of a set of n observations is actually the reciprocal of the arithmetic mean of the reciprocals of the given values, and this is how you can calculate it. So harmonic mean is actually 1 upon the arithmetic mean of the reciprocals uh, uh, of the observations. So here we have summation of all the reciprocals of the observations, and we took the arithmetic mean of all the reciprocals, and again we reciprocated to get the harmonic mean. This is how you actually calculate harmonic mean. So first of all, take the reciprocals of all observations, sum all these, divided by total number of observations, and again reciprocate the resultant one to get the harmonic mean. In case of frequency distribution, you can use this formula where this small n is here actually replaced with capital N, because here the arithmetic mean or the simple mean is actually calculated using total observations, and here capital N is actually the summation of all fi's. It means the total number of observations, and here is the summation of fi upon xi. So this is how you can calculate harmonic mean for frequency distribution. I will take a simple example where suppose an investor bought shares worth rupees 1000 US dollar for 2 consecutive months. It means in the first month 1000 US dollar and in the second month 1000 US dollar, a total of 2000 US dollar for 2 months. And the price of a share was US dollar 50 in first month, and it has increased to US dollar 200 in the second month. Now, what is the average purchase price here? This example is taken from Eminent Salab, a book of 2016 on data analysis and statistics. What actually is the solution? First of all, we'll have to calculate the number of shares purchased, and for that, what we actually do is we divide the invested money by the share price, and in the first month we got it by 1000 upon 50, that is 20, so 20 shares in the first month, and 1000 upon 200, that is equal to 5. It means 5 shares in the second month. So a total of 25 shares were purchased, and a total investment was 2000 US dollar in 2 months, for 1000 in the first month and the 1000 again in the second month. Second most important thing here is to get what is the weightage. The weightage of each purchase is same here because every month same amount of money is invested. So if we divide 2000 in two different months, then 1000 upon 2000 in the first month, that is 2.5, and 1000 upon 2000 in the second month, that is also 0.5. We have uh, mm, zero point 0.5 plus zero point 0.5, that is the summation of wi. Now we'll calculate average purchase price for you, and with that simple example, h is equal to summation of wi's, that is 1 here, and upon w1 dividing it by x1 plus w2 dividing it by x2. Here x1 is the purchase price in the first month, and x2 is the purchase price in the second month. And when you calculate this, you actually get 200 upon 2.5, that is 80. It means the average purchase price for this particular example is 80 US dollar for 2 consecutive months. Now I'm giving you a simple example here, which you will have to calculate and get me the answer, and drop the answer in the comment box. In case with the same example, if the invested money was 1200 US dollar in the first month and 800 US dollar in the second month, then calculate the average purchase price. I'm giving you a simple hint here that because in the first month and in the second month the invested money is now not same, so you will calculate the weightage first. And how you can calculate the weightage is I've already mentioned that take the investment in the first month dividing it by the total investment in the 2 months. So this is how you can calculate the uh, weightage, and just calculate it and put the answer in the comment box. Some more example. This example is from the book Fundamentals of Mathematical Statistics from Gupta and Kapoor. A cyclist pedals from her house to her college at a speed of 10 km per hour and back from the college to her house at 15 km per hour. Find the average speed. Here too, because you'll have to calculate the rates, so you should definitely use harmonic mean, not the simple arithmetic mean. It means 10 plus 15 and dividing it by 2. You will not get the real mean in that case. So we'll avoid arithmetic mean here, and we'll get to the harmonic mean. What is the solution? First of all, let the one side distance be x kilometer. So if you add up both sides distance, that would be 2x. Second, in going from house to college, what is the time required? So time can be calculated using the formula speed is equal to distance upon time. So time is actually the distance upon a speed. So distance is x from going to house to college and dividing it by 10, it means x by 10 hours. While coming from college to house, the time required is x upon 15 hours, because here the speed has increased from 10 to 15. Now the total time taken, that would be the time taken from going from house to college and coming from college to house, that is x by 10 plus x by 15. Now how you will calculate the average speed? By the simple formula, speed is actually equal to the total distance traveled upon total time taken. Here the total distance is 2x, total time we have calculated it for you, x by 10 plus x by 15. Here x can be cancelled out and you get this 2 upon 1 by 10 plus 1 by 15, and when you calculate this sum, actually you get 12 kilometer per hour. So this is how you can calculate the averages of rates using harmonic mean. One simple example or exercise for you, you will calculate the harmonic mean for me, and you will give the answer in the drop box or in the comment box. The example is, you can take a trip which entails traveling first 900 kilometer by train at an average speed of 60 kilometer per hour, then 3000 kilometer by boat at an average of 25 kilometer per hour, next 400 kilometer by plane at 350 kilometer per hour, and finally 15 kilometer by taxi at 25 kilometer per hour. Now what is the average speed for your entire travel? I'll give you a hint to calculate the average speed for your entire travel. Definitely you will have to use the formula of this rate, that is the speed is equal to distance upon time, and average speed would be total distance covered upon total time taken. Use weighted harmonic mean formula, and the second one, this speed formula, that is distance upon time, and you will get your answer here. Now, in the last but not the least, merits and demerits. The merits are as follows. It is rigidly defined like like others, like arithmetic mean and geometric mean. It is based on all observation, and it makes a skewed distribution a normal one, because it takes the reciprocals of the uh, mm, observations, and then take the arithmetic mean, then again reciprocate it. So just this process actually makes a distribution normal one. The third one, it is amenable to algebraic treatment or further calculations, but one demerit is actually related to this merit, that the treatment is very limited. It is not like arithmetic mean is used. The fourth one is not affected much by fluctuations of samplings as compared to geometric mean, and it gives comparatively more weight to small items, and as I have already mentioned, that is why in case of rates or and multiples, we don't use arithmetic mean, because arithmetic mean was giving more weightage to high data points. The second demerit, along with this very limited treatment, algebraic treatment and calculations, the one of the merit is demerits is, it's not easy to calculate and understand, as you have already seen that differentiating between when to calculate arithmetic mean and when not, it is very easy, but calculation of harmonic mean when there are n number of observations is not at all easy. So these are actually the merits and demerits. Thank you for being with me. Stay tuned with It's All About Economics for more videos. Thank you so much.